Hi, my name is Matt Honan. I'm the editor-in-chief of IT Technology Review. Here today to talk a little bit about scaling up enhanced geothermal. We're going to talk about some new technologies that are coming online. I believe the reason I'm here today is that in 2024 we put this on our list of 10 breakthrough technologies, enhanced geothermal systems. For the past 20 years, we've been highlighting technologies that we feel have really hit a tipping point where they are ready to have a significant impact on society, and it definitely seems to all of us that it was geothermal's time. And so today we're going to talk a little about what that means. As I think most of you know, geothermal comes with a lot of advantages. We're just hearing about some of them, but it comes with a lot of existing infrastructure, with existing engineering know-how, all kinds of things that it can leverage from the traditional oil and gas industry. It also has a lot of pretty significant challenges, even next generation geothermal. It's got everything from, it takes large capital expenditures. There can be significant permitting issues. People probably saw the BlackRock geothermal wound up suspending operations in the Salton Sea in large part due to permitting issues. And of course, it's trying to do something new and different, which is always hard to do in the industry. But today, we're going to hear from a group of people who are all working to develop novel solutions to tackle some of those challenges, from energy storage to drilling techniques to using AI. And so I'm delighted to be hosting this panel, and hopefully we're all going to learn something and come away with a better understanding of what's coming next. So let me welcome to the stage, please, Ghazal Izadi. She's the Chief Operating Officer for XGS. Mike Eros, the Chief Geoscientist with Sage Geosystems. Carl Holland, who's the Chief Executive Officer of Zanskar. And do we have Joss on our way? Joss is here. Joss is coming on stage right now. Jocelyn Lai, who's the CEO of Bedrock Energy. And while we're waiting for Joss, I'm going to go ahead and just start with you guys, if you don't mind. So I thought maybe we could start off by, you're all doing basically novel things. I thought maybe we could start off by talking a little bit about what some of your approaches are, and what you're doing that's a little bit different than what we may have seen in the past. And maybe, since we just go from one end to the other, Ghazal, can you talk to me a little bit about XGX technology and what you're doing?
Absolutely. Thanks for this opportunity, and especially to Jamie and the team to put this program together. So when we look at geothermal, our approach at XGS is to look at, as you heard from the previous talks, that when you look at the geomap, the heat is everywhere. So the way we look at the geothermal or heat extraction or energy extraction from the subsurface is how we can decouple geology and the water from the geothermal energy production. So our approach is that we are an advanced geothermal system solution that we don't use water. So basically, instead of fluid into the subsurface, we flow the heat. Our innovation and technology is the highly thermal conductive material. So we bring material science and advancement into the geothermal and subsurface well construction. So this material is highly conductive and transfer heat 60 to 80 times better than the rock. So we call rock is a lazy element. It means when you extract the heat from the subsurface, the heat is not flowing in the right rate. So our material is bringing the heat constantly to the working fluid, which is the water or any other working fluid in the fully closed loop system. Our working fluid never touched the rock, so few hundred barrels of the water per well circulating years and years in the closed loop system. And because the water never touched the rock, we also solve some other challenges around operation and maintenance, which we know not only on the subsurface piece, around the casing, around the wellheads, surface equipments, gathering system, piping, with corrosion and scaling. So we really want to have a system that we can control. So we remove all the upfront costs because we know heat is everywhere, how deep we need to go to access that, and then life cycle of this project. So how we can predict how much megawatt thermal or megawatt electric we can produce from one single geothermal well, and we really control the cost of the in the longevity of the well that is producing electricity. So that is how our approach. We completed our pilot project about 2 months ago. We are producing in one of the high temperature assets in California. So we are proud that the technology is deployed. We are moving to a more commercial projects in the Western US.
I'm sorry, where did you say your pilot project was?
In Central California, in the existing geothermal field at Coastal. It's a Navy land, China Lake.
Very good. And Mike, could you talk to us a little bit about SAGE, what you're doing with energy?
Absolutely. I'm very glad to be here. So I'm coming from Houston, Texas. I'm actually from West Virginia, but very happily educated by the taxpayers of California at the University of California, Davis. Giving a plug there. Yeah, you know, SAGE is at a beautiful point in our history. We're a 4-year-old company. Much like Ghazal mentioned, there's a huge focus right now on first-of-a-kind field demonstrations. SAGE is operating our first-of-a-kind geothermally pressured energy storage power plant just south of San Antonio, Texas, at a 3-megawatt scale. And this opens the door for us to leverage oil and gas technologies, which are proven today to scale geothermal by bringing those same technologies we're using to store energy underground, put it a little bit deeper, access heat. So we have a big focus on using and leveraging oil and gas tech to open the aperture, really, increase the size of the pie of energy around the United States and around the world. But primarily through, I would say, oil and gas technologies and innovation around them.
Very good. Carl, very San Francisco question, but can you tell us what you're doing with AI?
Yeah, appreciate that, Matt. And whereas many of the startups here, I think, are leveraging innovations and technology that came out of Houston, our company is really leaning into innovations that have come out of this area, San Francisco and the surroundings. And so we are the first company that is developing and commercializing AI models that can help you find and identify the best locations for geothermal development, somewhat agnostic to the various technologies or resource types that are out there. And so with all of the incredible potential that we have and the general maps of where the geothermal is, it still remains really challenging to drill the right wells. And we have many examples of geothermal fields where the difference between a well, say at the back of this room or the front of it, can be the difference between that project succeeding or failing. And so we employ massive data sets that include satellite, remote sensing, and ground-based data types. And we also have our own team members out collecting data on every day of the year. And we're now running at scale the largest exploration program for geothermal resources that the industry has seen in decades. And the good news is it's working. We've been able to build AI models that have now discovered more new hidden geothermal systems than any company in history, more in the last 3 years than the entire industry over the prior 3 decades combined. And maybe the most compelling example of this is our company, in the spirit of these first-of-a-kind full-scale commercial demonstrations, less than 12 months ago acquired an operating power plant in New Mexico that was actually at risk of being shut down and decommissioned due to resource challenges that it had run into over the years. And we were able to come in with advanced understanding and modeling of that system, and in less than 12 months have been able to drill a new well into a new resource that was 4 times deeper than the prior production zone, and that is now slated within 2 weeks to be connected to the grid and fully restoring that power plant back to its initial capacity. And so very excited to see that as the first of many future projects where we'll be able to apply AI to increase the confidence and the profitability of these projects.
That's fascinating. And Jocelyn, is it Jocelyn or Joss?
Jocelyn is great.
Jocelyn. Can you tell us a little bit about Bedrock and your technology and what you're doing differently than, or what you're doing in terms of novel technologies?
Yeah, so I think my colleagues on the stage here are doing incredible things to figure out how do we at scale commercialize geothermal heat to power. And at Bedrock, we actually focus on a different category of geothermal that is on the shallower and more everyday, shall we say, end of the spectrum, which is that you can actually use the much shallower, about first 1,000 feet of the ground as a heat sink and a heat source for heating and cooling for buildings and other forms of direct use like agriculture, aquaculture, and light industrial facilities. And this type of geothermal heating and cooling has been around for 100 years and is pretty common. Every state in the United States, every country in Europe, most countries in East Asia already have geothermal heating and cooling. And so what we focus on at Bedrock is how do we install those systems in a backyard, in a parking lot, in an urban municipal district much faster, much cheaper, so that it can be a distributed energy category the same way solar has scaled over the last 30 years. And so, like many of my colleagues, maybe less so Zanskar, but we utilize oil and gas technologies for the purposes of automating and speeding up and optimizing the construction of geothermal heating and cooling systems for buildings and campuses and really everyday purposes.
Can you talk to me about a little bit about how is it similar to or different than traditional HVAC?
Yeah, so with traditional HVAC, you either burn fossil fuels right in your building in order to create heat, or you are exchanging heat with the air outside. So when it's a chilly, 40-degree, temperature outside, and you're trying to generate heat from that, or if it's 95 degrees outside and you're trying to generate cooling with that, it's not very efficient. But the ground is always in that first 1,000 foot, almost everywhere in the world. It's just a really comfortable, 60 degrees, 7 degrees Fahrenheit, which is conveniently what human beings really like. And so if you use that nice 60, 70 degree Fahrenheit temperature gradient in that first 1,000 feet, you actually get way more efficient heating and cooling because you're just moving heat in and out of the ground to the liking of the occupants of the building.
So when I was introducing this panel, I was talking about how we had put enhanced geothermal on our 10 breakthrough technologies list in 2024. And one of the things that we always ask ourselves when we're putting those lists together about a technology is why now? And it does seem like geothermal is having this big moment right now. I'm curious, being a founder, being at a startup is a significant investment of your time and energy. It can be grueling. I'm curious why now, why you think now is the moment for geothermal. Any of you can take this that you'd like.
Well, I'll just jump in and say because we have the tools that we need. We are at a beautiful point where folks like Levering, who used to be chief scientist at Weatherford, prior to that at Shell, these folks have proven in the oil field that these technologies can work safely, and can be done today. And so, at Sage, for example, we're bringing things to market now from start to finish in 18 months, maybe 36 in a more complicated area, but we're not using necessarily space-age tech, and thanks to work from companies like Fervo and others, the drilling costs have been going down significantly. So we are now able to actually compete for cost of power, 9 to 7 cents per kilowatt hour in our work. And so that's very exciting. That's not something that was even possible to dream of 5 years ago.
Does that ring true for you?
I think the market signal could not be stronger in terms of the power need because of what you saw in the last chart. So if today we are using between 200 to 400 terawatt hour of power we need, and in next 5 years we want to, in some cases, 10 times more, where the power is coming from. So geothermal can, if you look at the map, yes, there is a gas turbine, there is a geothermal, there is a nuclear, there is other renewables. Other renewables, they are not base load. Nuclear is a different life cycle to build this project. Gas turbine has their own challenges in terms of supply chain and meet the market demand. Geothermal. So if you look at the co-location between the heat resource and the power center, data center cluster, you cannot find a better match. So let's use the heat below our feet and convert it to the power and make sure that we can support the future of AI. That makes our life is much easier. So it's a codependent market needs and what we can deliver through our technology, which enables us to get to the power, clean baseload power much faster and cheaper.
And Mike, you alluded to this, but I know I think at least 2 of you have oil and gas industry experience. Do all 4 of you? So 3 of you. Okay. Talk to me a little bit about how you've leveraged what you learned in the oil and gas industry and how that's influenced your approach. And whoever would like to take that again can do so.
I spent about 13 years in oil service company. Started when the shale gas and shale boom started with the new technology on horizontal drilling, fracking, and how we accelerate the project development in 10 years from 80 days of the well construction to 5 days today. That is about efficiency and cost reduction and a scale up. So this is exactly the same approach that we need to do. And with all these people here sitting here, they have that mindset that this is how we can make geothermal in the bigger part of the pie. So my experience from oil and gas, we know how to better assess the subsurface in terms of resource assessment at a well level, how we can have a very efficient well design in terms of less material, less weight, how we bring and move the equipment at the site. When we come to the field development, it's about field management. Hydrocarbon extraction and management is the same as heat extraction and management. So running this field efficient, how many wells, at what operational parameter to run this to be cost efficient, this is how we know to do it from the oil and gas. So we just need to adapt with the different variables and metrics here.
Carl, is there a similar story around AI there?
Yeah, I think there's often been these learnings that are going back and forth between, say, Houston and Silicon Valley. And sometimes out here we like to think, oh, Houston's a slow-moving, kind of old-school way of doing things, and they're not very innovative. But I actually think that's as far from the truth as possible. When you go inside these companies, they've been dealing with really hard problems, massive data sets, and huge infrastructure build-out. And they are actually world-class at doing those types of things. And so when we looked at, why wasn't AI being used more actively in these spaces to solve these problems, it was not just that they were avoiding it, it's that this is a really hard challenge. It's a series of decisions that you have to make when you're exploring and developing a project, and all of those decisions are made under extreme uncertainty, sometimes with sparse, complex 3 or 4 dimensional data sets. And so kind of also to your prior question, to us, we think several of these tailwinds converged at the same time, where there was now market demand for more power, but the thing that was driving that demand, this advent of new forms of AI, was also in some ways, we think, the solution to helping to accelerate our ability to add more power. And so for us, we also see the progress of AI and the problems that it can solve in their complexity, from, say, beating somebody at checkers in the early 90s, chess in the late 90s, games like Go in the 2000s. It's only been in the last few years that we've seen these models become complex enough and large enough in scale and parameter count that they can actually tackle these types of problems that the subsurface industries have been dealing with for decades. And when you look at some of those innovations, some of those actually came from Houston, some of the early statistical models or computational capabilities. And so the trade between the two, I think, is healthy and needs to continue.
Were there specific breakthroughs in AI? Was it data set size? Were there specific breakthroughs that led you to this moment?
Yeah, in particular, our company comes out of 2 different, actually DOE-funded efforts. One was looking at large spatial data sets and applying machine learning models that are optimized for these types of spatial analyses so that you can better predict or pinpoint locations of interest. But perhaps even more importantly is a new form of AI that came out of Stanford Labs in the last 5 to 10 years called Bayesian evidential learning, which really relies on massive simulations and large compute to be able to run all of the physical possibilities of what you might encounter in the subsurface and use that as part of the model performance.
You were looking like you wanted to weigh in on, or
Sure. If I could, maybe just a couple of points. I agree with everything, especially because Gazal said. And there's an opportunity we have to not only leverage the very, very difficult technology know-how, but also the workforce. It's 6 million people or more from oil and gas, maybe 60,000 right now in geothermal. Like Jamie Beard says, if we're going to change the direction of the ship, we need to work with the sailors we have. And worldwide, that's really an oil and gas story. So I bring that experience from oil and gas to think about, like Gazal said, how do you scale this effectively? The second point I'd say is doing it safely. And so, Cindy, my boss, Cindy Taft, CEO of Sage, had to work very closely with folks in Texas, one of the most difficult places, I would say, to gain alignment politically, to very quickly in that state achieve goals which really help our energy security needs, but also in a bipartisan way, bring forward geothermal as a solution and regulate ourselves like we did oil and gas. So oil and gas provides a pathway for safe, reliable operations. in ways that the country can put under scrutiny. It's an exciting time for that reason.
I want to come back to this question about bipartisanship, but before I do, and I'm going to start with Jocelyn this time. Can you talk to me a little about some of the challenges that you've faced, maybe especially ones that you've learned from and have been able to overcome? And I'd love to hear from each of you on this, but maybe we can start over there at this side this time.
Yeah, I think one thing, while I think geothermal of all kinds really benefits from the know-how in the oil and gas industry, one thing about distributed geothermal, which is around kind of like standardized rinse and repeat projects, is that the economics have to look very different, and then the project life cycle looks very different. So one of the challenges that we've had to do with a team that is similarly 60% from oil and gas is to re-engineer a lot of the mindset, right? In oil and gas, on the oil field, you have so many vendors, and this might be the case in large centralized geothermal projects. You have many vendors specializing in different things. You have a lot of people and a lot of money going into one large like infrastructure project. In distributed energy, you have to cut a lot of that out. You have to have your people, your technology do kind of like full life cycle responsibility so that the economics can be really, really, really tight and streamlined, so you can do this over and over and over again. Think about the difference between a large grid-scale solar project or a wind project and a rooftop solar project. You can't have 7 different vendors on site on a house or a commercial building. You have to really, really tighten it up. So that's one of the challenges that we've had to do in our taking our oil and gas DNA into distributed energy, and then bring that value prop to the end customer, which in our case might be a real estate developer or a commercial building operator. And those are pretty different folks that you have to do a lot of that code switching among.
Carl, can you weigh in there?
Yeah, I think really when you look at the spectrum of geothermal startups that are out there, they don't look like Silicon Valley startups. They're not just building software. They're not just building a technology to license. Most of them have opted for a more vertically integrated model. And I think some of that might be necessity. It might be that the industry is still so small, there's really no one to sell that into. But I think the other part of it is that in many cases it leads to faster learning cycles. When you're out deploying your own technology and you're the user of your own technology in real projects or in the field, you can take those learnings right back in. And so, at least in our case, we had found that early on, we knew we needed to be in the field deploying our tools, and then coming back with that data to then update the models, change what we're doing. And that's been a really healthy part of our technology development and learning cycle, but it has certainly led to much more complexity from an operational point of view. It means safety has to be first and paramount in all of your operations, and the operational skill sets needed look very different than I think the typical software operational skill sets. And so merging the physical reality of your business with deep tech and hard tech innovation, I think has been a culture, 2 cultures that you're pulling together that in our case has led to better outcomes.
And I'm curious, so when you're hiring, are you looking more towards the Silicon Valley types or the 6 million people who already work in oil and gas or some combination? Like how are you finding people who can work on solving those problems?
So our team comes from both. We have team members that have worked at the oil and gas majors on the service side and on the operator side, and we have team members that have come from Silicon Valley that have worked at some of the major tech companies, and they do bring different perspectives to the table, and sometimes that can lead to conflict in how we want to approach this. Everything from how do you manage projects in a sprint style versus a waterfall style, but I think those conversations are healthy, and they've led us to, I think, more innovative ways to approach the problem.
Mike, can you talk to me about some of the challenges you've seen and how you guys have gone
Technology. Sorry,
you talked about some of the challenges that you face and how you've gotten past them, what you've learned.
Yeah, I think it's a great question. Initially, part of it is the messaging and just getting the word out about even what geothermal could be. The idea that you can drill a vertical well and create a modern day fracture system, man-made, 10,000 feet under the ground to access 200 Celsius rock, which is not something that oil and gas has really spent much time doing, but now we are doing in the field in Texas, much like Fervo Energy is doing out west. Just getting people's minds around what that even means visually, and then also getting to communicate around how this is a commercially viable prospect. There's a lot of, I think, for good reason, skepticism publicly around the world about how is geothermal changing today? Why is this decade different than the 100 years that were previous? Where most, let's be honest, geothermal companies have gone by the wayside. When you're looking For example, in Nevada, or we did analysis for Turkey, historically you might have 40% of the wells fail within 5 years, which is this huge capital investment loss, which can cripple companies. So you have to really prove, I think now, in a more challenging way, why there is a commercial prospect. And getting to that point is really critical, in my opinion, to turn the story and really get the investment, which we know is there.
And Ghazal, can you talk to me about what you've learned?
So my story is a little bit interesting. Being in oil and gas, 10 years living in Silicon Valley, and oil and gas pushed me to be in this environment for innovation, and then moved to Geothermal, a startup company. I think we know that this is about the capital we need and when. So as a startup, we backed up usually with the venture capital support and funding because they want innovation, right? When the technology is proven, you go to the commercial phase, you need a different type of capital, right? Because you want to build up and scale the project, so the financeability of the project is important, how much you de-risk the technology and overall deliverability, and in our case is a power or heat. So I think the opportunity here is that as a startup company with a very limited resources, either coming from oil and gas or from the Silicon Valley with different background on data engineer, machine learning, mechanical engineer, all the resources that we need to generate power, how we are building the right execution partner. So I think for all of us, the main execution partner is oilfield services because they know better than anybody to how to drill the well, how develop the field. We need to have the mindset of the business model and financing the project from the E&P company like ExxonMobil, Shell. They know how to do it. When it comes to the power, we need to know how the utility think, right? So I think for us, the opportunity is to really rely on all of this skill set and couple it for the successful business model to make sure that, I mean, we are going to be successful no matter what, right? All of these companies sitting here, they show that geothermal works and it can be at scale, and with the innovation, we can do it. It's about the cost, speed to the market, and how the basically supply chain is going to help us to make this project faster online.
We are going to be successful no matter what is such a founder mindset. It's totally. The question that brings to mind for me, though, and you mentioned it, and Mike mentioned it, Carl, you alluded to it, like, is there are huge capital expenditures in your industry that are very different than a traditional Silicon Valley startup. It's a software startup, and something that I'm hearing when I talk to investors right now, today in 2025, is we have no idea what's coming, and it makes us very reluctant to invest. And I'm curious what advice you would have for other potential startup founders who are especially looking into geothermal, which is going to take these huge capital outlays. What advice would you have for them who are in that environment right now, who are looking at starting a company?
Well, I'll just mention that we partner with a company called the San Miguel Electrical Co-op, a utility company based just south of San Antonio. And we like partnering with them. I like partnering with them because they're not the tiniest company, but they're not the biggest. They're hungry for change. They see need for change. They approached us when they saw that we had some new technologies, and they said, we have this old coal-fired power plant that we are faced with the future of. How are we going to potentially add solar power to it? We hear that you can store energy underground as high-pressure water to replace batteries for 10, 12-hour duration energy release at maybe a much lower cost than all those batteries would cost. Talk to us about that. So I would say approach companies that have a need and a practical interest in partnership, and don't worry necessarily about attracting the biggest guy on the field, because when you work with folks who really want to collaborate and make change, that's the advantage of a startup, is that you can move quicker. I can get that permit now with these guys in Texas within 2 months, and now we drilled a well in October, and look at that, isn't that great? So you start to build on your success, and you also, for us, have to have a bias to the field, in my opinion. I would say that for startups is really try to work in the field where you can, because you're going to have, like you said, Carl, you're going to have to learn the hard way and the good way by comparing not just your model, but looking at your reality.
Jocelyn, do you have thoughts on that?
I think that this point on really needing to have that experience in the field is so critical because Carl's point about how we are everything. You are a technology company. You're also an operator. You also basically have to figure out how to finance these systems. You're working with folks on the subsurface operations. You're working with the utility. You're working with the landowner. You're working with the regulator. And so the complexity of all of that is such that you really can't outsource any of it. And if you outsource any of it, you will not get the data you need to validate what you're doing. And without that validation, you're not going to create a category, which is what we're up here to do. To not just deploy 1 or 2 sites, but to have the learning cycles. You get so much data that this can be done over and over again across the United States and around the world. So I think that means that there's a much higher burden and therefore costs in the earliest days of really getting your hands dirty across every single one of those operational exigencies. And it's really expensive. And I don't think every venture capital fund understands that deeply, especially if their DNA is to have backed a lot of SaaS over the last 15 years. And so a really big part is finding good partners who understand the operational burden of what we're doing, the importance of getting out there and drilling real holes and getting real subsurface data, which is really, really capital intensive. But yeah, I think the fact that there's a geothermal house, the fact that we're all folks here leading companies in that space is a signal that the capital markets and I think the technology and energy innovation ecosystem is starting to wrap their heads around that.
Go ahead.
Oh yeah, I was going to add. I agree. It is capital intensive. It's asset intensive. But so are a lot of SaaS businesses. A lot of them spend and raise a lot of capital to get to scale, to capture their customers. And one of the things that a power-producing technology has is an advantage that there's almost infinite demand for it. So the product market fit is not something that we all worry about on a day-to-day basis. We worry about making the thing work. And once it works, that demand is there. And so for us, it has been more about finding the right partners and investors that really share that vision, understand the business model and the capital needs over time, and what those key inflection points are. And in our case, some of those have been traditional Silicon Valley or venture-style investors. Union Square Ventures out of New York co-led our Series A. But we've also had deep tech and hard tech and climate tech investors like Lower Carbon or Obvious Ventures on our cap table. And it's been critical to be aligned with them. In our case, it's also critical to have optionality. We all have big moonshots that we want to take, but we also need to know what is the least resistance, lowest capital path to get to profitability. And so for us, that's one of the reasons we've started with conventional hydrothermal, geothermal resources. They work today, and there's already banking institutions ready to come in and finance those projects once they're de-risked. And so for us, it provides a pathway to start unlocking more geothermal, building more of that supply chain, so that as these next generation forms of geothermal come to market, we're ready to help deploy in that space as well.
Are any of you, I'm just out of curiosity, working closely with any of the big data centers or big tech company data centers?
Yes.
Can you tell me more about that?
Yes, so Sage signed an agreement with Meta, the Facebook parent company, last year to provide 5 to 8 megawatts of renewable geothermal energy somewhere, we say, east of the Rockies by 2027 to scale to about 150 megawatts by 2030. So we put that out there. They've agreed to purchase that power. That gives us a strong incentive to build, mainly because, as you've all alluded to, the data center needs are quite high, yeah, potentially. Really. I mean, the multiplier, I think, is still to be understood, but an add-on for sure. And so, and I'll just say we've also been speaking with, let's say, 5 of the other top 10 data center companies in the world who are also struggling with this reality.
And are you finding are they coming to you? Are they hungry for these? I mean, because I know that they're also very concerned about emissions, or a lot of them are, or expressed to be. And are they coming to you? Are they seeking you out?
Yes, they're definitely asking to learn more. It's funny to get an email from a geologist who works for Facebook. That's the first time that ever happened to me. I'm part of the guild of geologists, I would say, and we wear different hats for different companies, and that's great. But they're really investing time and effort now.
I see. Did you want to weigh in here? You were looking at me like you might.
No, I just wanted to touch a little bit on when we talk about the financing and raising money for a startup, we need to think strategically. So how we want to fill our cap table. So we need some VC capital, we want some strategic capital. For example, in our case, we brought both from oil and gas, and one of our lead investors is Constellation, which is biggest green power generation in the US. Their portfolio is around hydro, nuclear, wind, and solar. Now they bought Calpine, which is biggest asset in California. Now they invest in the next generation technology like XGS. We bring nuclear executive, our investor here from, for example, Clear Sky. They think differently, right? So I think what we think about it is there's a subsurface piece and a surface piece. Surface piece, nobody can do it better than nuclear industry. Subsurface is nobody better than oil and gas. So I think that is another way we think about how we build this ecosystem internally and in terms of the financing to make this project more successful. And it's all about efficiency and cost reduction and the learning curve. So we need to have those people around the table to support us.
Very good. I'm going to come back to that bipartisan point that I mentioned earlier. At the start of the new administration, it seemed like there was an enormous amount of optimism around geothermal, precisely because it seemed like a bipartisan issue. The sort of traditional clean energy climate folks were on board, and you also had people like Chris Wright and others who it seemed like this is a real moment for geothermal to have support from both sides, which is incredibly rare, obviously, for anything to have support from both sides. I'm wondering now, with being a couple of months in, a few months in, if that's still the view, if things have changed. How bipartisan and optimistic are people feeling today? Mike, you're nodding.
Yeah, I'm sure. I'm happy to say that. We don't know what the tariffs are going to mean, for example, for the future. I'm not here to prognosticate on that. I agree that having a U.S. Secretary of Energy who at least is talking about geothermal is a positive for our industry, for sure. And yes, the bipartisan view on Capitol Hill and also in many state houses is very encouraging. I was in Alaska 3 weeks ago speaking with about 40% of that legislature, and it was remarkable to see what you just said. Folks looking at energy poverty rising with cost of natural gas in many parts of the country, looking at optionality. How do we fight poverty in this way? Do you have a solution? The devil will be in the details a little bit. In the past, I would say geothermal has been, as Jamie has said, kind of a redheaded stepchild. You look at the Inflation Reduction Act in 2022, which had maybe $2 billion of investment slated for hydrogen and carbon capture. Geothermal had about, I think it was maybe $84 million. So, we're not saying give us $2 billion, that would be great. But we are saying instead of the United States just funding one pilot for the entire country, maybe we could try 5 pilots and use taxpayer money in a smart way. And so that's kind of the conversation we're hoping to promote.
And Carl, I'm going to put you on the spot too. Sorry.
Yeah, no, we think it's actually a really exciting outcome to see true bipartisanship on this issue. Obviously, the reasons and the language is sometimes different, whether it's about resilience and American power and redeploying American workforce, or whether it's about decarbonizing the grid and building for long-term sustainability. The actual solution tends to be the same for both of those, and so geothermal fits this unique spot. Our company is based in the state of Utah, which is known for being typically on the right of the spectrum, and we are seeing a lot of support within our state. And also where we're operating a power plant in New Mexico, we're seeing a lot of support from that state. On both sides of the aisle seem to be coming together looking for solutions. When we started our company, it was far harder to permit a geothermal well than an oil and gas well. It could take us years to get a permit that oil and gas could get in weeks to months. And we're seeing real changes in that now. And prior, it was also, geothermal often did not get the same tax treatment that solar and wind got as a renewable form of energy. And we've seen that progress made as well. And so in general, we're feeling very optimistic and think that there's a long road of support ahead. But I agree with Mike, there's still things and uncertainties around tariffs, tax credit at risk that we're watching very closely right now.
I want to come back to the permitting that you mentioned, but before we do that, I would like to ask about tariffs. It does seem like, compared to like solar, geothermal is in a much better shape. You still have a lot more, domestic supply chains are based here, but then when you think about things like steel, it seems like you're going to be in a tough spot here. And I'm wondering if, I would love to know what you're thinking, how you think the tariffs are going to affect your ability to build in the next few years. And Jocelyn, we can maybe start with you this time.
I mean, I think this is probably consistent across all of our categories, which is that on one hand, the tariff's intent is to protect things like geothermal energy, which is drilled in the United States, done so with American labor, and drawing on energy that comes from American land. Now, I think it's about execution, which is that all of us, even if we're using drillers who are based in the United States, well, where does their steel come from? Or where do their parts on their equipment come from? And I think it's just ultimately around, there's a bit of a wait and see, and then I think there's a bit of engaging with folks on the Hill to really push for protection for our space, because we know that the intent of the tariffs is to protect American industry. So that's my high level response on that. I think at Bedrock, we generally know that for the most part, maybe like the end products that we are buying or the equipment that we're utilizing is probably assembled and produced in the United States, but the trickle-down effect for tariffs is just, whether our suppliers will then be passing on any of their costs in their supply chain. So we're a little bit in a wait-and-see mode on that.
You had a thought there?
Yeah, I agree with that. And I think where we're sort of seeing this maybe most painful for geothermal startups is really in the offtake market. There's a lot of uncertainty right now as to how is this going to affect PPA prices. And so conversations that are underway or red lines that are happening, I think there's this question of what does change of law do to these contracts? Who's going to foot the bill if tariffs end up factoring in? But in terms of the long term, I do think geothermal is less exposed than many of the other renewable forms of energy. Aside from things like, say, steel or transformers, the turbine supply is typically with partners to the United States that are going to be lower on that list of tariff relative to, say, solar, wind, and battery.
I want to go back to permitting. I mentioned at the outset, I don't know if you heard talking about these Salton Sea projects that were suspended. It does seem like you do still face a number of permitting issues among other issues, and I'm curious what types of policy changes you would like to see, that you would like to, especially if you do feel like you have some bipartisan wind at your backs now, what types of policy changes would you like to see happen for the industry? Ghazal, would you like to start there?
Yeah, I think especially in the area that we are talking about, the power need like California, Utah, Nevada, New Mexico, that most of us is going to be active. We know that there is a term called KGRA, Known Geothermal Resource Area, that is defined, and you can get a fast-track permitting in the matter of 30 days to 3 months. A little bit going out of that, which usually there is no steam field, right? But we still have heat, and we can tap into that for the geothermal development. I think those are the things that I would like to see, that if there is a KGRA, and if you go out of this boundary, right, you know that there is a multi-100 megawatt power generated. There is a drilling, right, for many years. I mean, they started to drill around 90, 80. But when you go a little bit 1 mile, 2 mile away from these areas, it is 2 years, 3 years of the timeline and lead time for permitting. So from 30 days to 2 years. So I would like to see that how we are going to fast track those opportunities. I'm not talking about the greenfield that nobody knows what's going on, but around those known geothermal resource area, we should be able to build a project because we know there is heat, right?
Go ahead.
Yeah, I would say it's really great to see Democrats from New York working with Republicans from Utah at the U.S. Capitol in the last 6 months to address your question and to say streamlining permitting doesn't have to be a bad thing, a priority. And for all the reasons Ghazal said, in the United States, it is very challenging. You know, we're talking with folks even in New York and Pennsylvania, PJM, very large utility areas, which, while they might not be in the most hot regions, they're perfect for storing solar and wind underground as high-pressure water. But to do that, you need to permit wells. And that's a process which a lot of these states, frankly, are doing at a slower rate than we could really use. So leveraging what we know to work around the country would be great. Getting a little bit more technocratic, nerdy energy around that would be great. And I think we can do that.
We have a few minutes left, and I just wanted to give each of you a chance to basically give any final thoughts you may have today. And since we started on this end and went that way before, Jocelyn, can I start with you? Is there any final thoughts that you've got?
Sure. I think being the representative of low-temperature geothermal on this stage, like so often the takeaway that I leave is it's an all of the above this is an all-above strategy that geothermal offers, that there is geothermal of all kinds just everywhere in the world, and even in places like San Francisco, where you're not necessarily getting super high temperatures to generate power. There is geothermal for heating and cooling, and it's already done in the city of San Francisco and a number of municipalities across California. And so I think there's a lot of curious lay people who are exploring geothermal in this day as its, I think, stature rises in energy discourse. And one of the big things I say is, it truly is everywhere, and you could have it in your backyard if you wanted.
I would agree with that. Within geothermal, it is a little bit of an everything under the geothermal spectrum, and I think because of that, because we're pursuing some that are higher risk and some that are proven today, we're going to see failures. And I think we as an industry and those watching it need to anticipate that and not be surprised. We're going to see some companies ultimately find that the technology doesn't work. Either they pivot or they're going to have to go out of business. And that does not mean all of geothermal is failing or that the sky is falling, because we already know geothermal is delivering power today. It has been for 100 years around the planet. And many of these technologies are already scaling. And at Zanscar, we see a pipeline of gigawatts just within our own portfolio that doesn't require any new technology breakthrough. It just requires unlocking some of these permitting barriers and providing the capital for these projects to be developed. And so it's more just that sensitivity towards it's good that we're pursuing all of these, and don't be alarmed when a few of them don't work.
I'd say it's a great time to awaken the child in all of you as U.S. taxpayers, as anybody who's interested in the earth, and say we expect more, both from this industry and from other industries, to give us better solutions that are commercial, that are safe, but are also right under our feet. And so, it's hard to perceive necessarily, but the United States is a world leader in this. I mean, Turkey has certainly carried the flame for a long time, Iceland as well, but we're at a unique, wonderful opportunity where all the right pieces are coming together to really test these ideas. And we're going to learn a lot. Let's learn more. Let's learn faster.
So first of all, happy Earth Day. It was yesterday. So my point here is I would like to leave you with the number we heard about oil and gas drilling versus geothermal, which is 70,000 per year. And geothermal is still, we are less than 100. So what we want to do with all the Brian's mind that really pushing in this area to bring the technology that we can reach to the hot rock faster, cheaper, extract the heat more efficient. I think this is what we try, all of us try to do. I think it's a big complementary. All of us can be successful and need to be successful. And then that between 5 states in the US, Western US, we have a potential of the power generation around 20 gigawatts. So imagine how many wells we need to drill and how much we can support the demand for the green power. So let's help the citizen on the grid to bring the geothermal on the grid.
Cool. Well, thank you so much, everybody. Can I get a big hand for our panel here? Thank you.